Ripple Effect, sponsored by Suez.
I'm not a scientist, okay? But I could tell you this. It's easy in my mind to look at it this way. In the time that I've been around, which isn't that long in the scheme of things, we have gained 100 million people in the United States. The world population has increased by 3 billion. There has to be an impact of that.
Amidst one of the worst droughts in California's history, water remains at the forefront of agricultural issues.
Typical water level would be around this point.
How much water has completely taken over the downtown area?
If those sea levels rise by 5 feet, as some experts predict, by the end of the century, all of those beach towns there would be underwater.
Beyond human population growth and development, extreme weather events like droughts, floods, and superstorms will have a direct impact on water scarcity and water's worldwide distribution. To soften that impact, we need to proactively plan for the future.
Climate is very complex and complicated, and to say something like the climate is warming or cooling does not do justice to the complexities that occur at a local level. You can have catastrophic flooding occurring in Bangladesh, the same time you have catastrophic droughts occurring in Yemen and Sudan and Nigeria. But the patterns seem to hold that as the global temperatures continue to increase, the wet areas get wetter, the dry areas get drier.
The best example I can come up is the most recent one, that's California. So they had a very long, 5-6 year drought. And then all of a sudden, this year they got an overabundance of water. This is the kind of impact we're looking at.
So we see an increase in extremes of both temperature and precipitation, often changing together.
One of the big questions I get from a lot of the people that are in water infrastructure in some of the big cities is, tell me how extreme events are going to change.
They have documentation of what are called 500-year events, 100-year events, 5-year events, but you're really out looking at 100-year type events or less.
We do expect the number of heavy rainfall events to increase, and so for any location, the 100-year, 24-hour return period, which would be the amount of rain that you expect to happen once a year or on average about every 100 years, for a 24-hour period, it may be 8 inches. Well, in the future, it may be 10 inches.
An increase in just 2 inches of rainfall from a heavy storm can tax our water infrastructure beyond what it was built to handle.
So this is something we need to kind of address, and we need to address it through technology and policy. And on the policy front, governments can really do 4 main things. So the first thing is education and outreach. They can explain to businesses and communities it's not only important to reuse water, but it's safe to do so, because that's a big area of concern.
You really need to educate not only the consumer so that they're pushing from their end, but you need to educate the regulators, the key stakeholders that need to work together, in order to make something like this happen.
The second thing is remove barriers to reusing water. Water is almost universally underpriced, so it's cheaper to take water from a river or the ground or even a potable municipal system than it is to buy and implement water reuse technologies. And then the third thing you can do is provide incentives. The government can provide a tax incentive, just like for wind, you could do that for water, or they could provide grant money or some kind of other subsidized loan.
We have seen, success in, even short-term incentives sparking that innovation.
And then the fourth thing is mandates. In other words, governments can simply say, we don't have enough water to go around, you must reuse water. And we've seen that in places like Australia and Canada. Israel reusing 85 to 90% of its water today. Again, an accident? No, all driven by smart government policies.
Innovations in local infrastructure, distribution, technology, and water reuse all will help shape smart water policy for future generations.
I think in the United States, setting an aspirational goal for ensuring that we have a sustainable supply of water, like many other countries have done, would be a great first step and wouldn't cost the federal government anything. So you would say something like, hey, we're reusing 6 to 8% of our wastewater today. Let's set a national goal of reusing 10 or 15% over the next 10 or 15 years. And any reuse technology we implement today to treat wastewater for reuse, so it is sustainably increasing our supply of water forever.
Technology, economics, policy, and a cultural shift in how we live our lives will all play a significant role in shaping meaningful change.